All right, so today we're going to talk about unit analysis. And unit analysis is just a way to convert units. It's a way to do so that we can keep track of whether we should be multiplying by a conversion factor or dividing or what. We're going to let the units do all that work for us. Okay? So, like I said, the objective here is we're going to talk about ratios and rates, but we're basically converting units. And then we're going to use that idea of converting to make sure that in a real life situation we're comparing the same units, so we can compare apples to apples and see what's going on there. Okay, so we start with some vocabulary. Always with some vocabulary, and these are things again that you guys need to commit to memory. Very easy points on the test. Like I said, unit analysis is what we use to change the units of a quantity. And we're going to write some ratios. Ratios compare two quantities by division. So basically fractions. We're going to create some fractions to convert our units over. A rate is a ratio that compares quantities measured in different units. Miles per hour is a rate. We're comparing miles and hours, so they're in different units for the two quantities. Okay. A unit rate is when we do that, and we do that so that the denominator has 1 unit. Miles per hour is an example of a unit rate. If you're going 65 miles per hour, then you're going to travel 65 miles in 1 hour. So our denominator is 1. And then the last thing here, we're going to use a conversion factor to create our ratios that are going to help us change our units. Conversion factor is 2 equivalent measures in different units. And for example, 3 feet is 1 yard, and we're going to write that out as a ratio, as a fraction. So 3 feet over 1 yard, maybe. Or we can always go 1 yard over 3 feet, and we're going to use that. But that's the same length. 3 feet and 1 yard is what we mean by equivalent measures, that they're the same length. They're just written differently because they're in different units. And we're going to use that to help us convert. Okay, it's these conversion factors, conversion fractions, you'll hear me call them. That kind of thing. So let's get to it. We want to convert 3.2 miles to feet. Okay? So do we need to multiply by 5,280 feet or divide? What are we supposed to do? Unit analysis is our way of placing units in this fraction right here. This is our conversion factor fraction. Right? I know that there are 5,280 feet in every 1 mile. So in this fraction, where do I put the feet? Where do I put the miles? Unit analysis says this. When I'm finished multiplying this fraction by this fraction, I want to do so that miles divide out and I'm left with feet, because I'm moving from miles to feet. In order to do that, I've got miles in the numerator. So in order to divide out miles when I multiply all this stuff out, I've got to have miles in the denominator. That way, and you can look at it in terms of cross-simplifying, these miles will divide out. If I put miles in the denominator, I'm using that conversion factor, right? Miles to feet. So if I have miles in the denominator, I'm going to put feet in the numerator. Those are our units. I haven't placed any numbers yet. I'm going to do that now. I know that there are 5,280 feet in 1 mile. And so that will tell me that I need to multiply this fraction, which basically means I'm going to multiply straight across. 3.2 times 5,280. I'm just going to get 3.2 times 5,280. And then 1 times 1 is 1. And I'm going to have feet as units in the numerator still. Okay? So all I got to do is multiply 3.2 times 5,280, and I get 16,896 feet. So there are 16,896 feet in 3.2 miles. unit analysis showed me that I had to multiply 3.2 by 5,280 instead of divide. That's the idea. Okay? Same thing here. If I want to convert seconds to minutes, I'm going to create a conversion fraction that I'm going to multiply this first fraction by. I want seconds to divide out and therefore have minutes left out. I'm going to put seconds and minutes somewhere in this fraction. The question is where? Well, since seconds are in the numerator here, I need to put seconds in the denominator here so that they'll divide out. And that's the case. If that's the case, I'm going to have minutes sitting up here in the numerator. I know that in 1 minute there's 60 seconds. And so now I multiply straight across. 11,256 times 1 is just 11,256. 1 times 60 is 60, and minutes are in the numerator. So this tells me I have to divide 11,256 by 60 and get 187.6 minutes. Okay? We're just trying to place units so that the right units divide out and I'm left with the units I want. Okay? Try this one on your own. You create your unit rate first, right? We make a unit rate by just putting this over 1. And then create your converting rate, your conversion factor, your conversion fraction on your own. See what you come up with. Start the video back up and see if you're right. Did you get 8.675? Okay, again, I want centimeters to divide out. So I've got to have centimeters in the numerator and centimeters in the denominator of my two fractions. That means I have to put meters up in the numerator of my converting fraction. And then I multiply straight across and divide out what I'm left with, and I get 8.675 meters. Okay. Now, notice that we needed one conversion fraction to convert 1 unit. We're converting 1 unit from centimeters to meters. What if I wanted to convert 2 units? If I wanted to convert feet to miles and seconds to hours, how many conversion fractions are we going to need there? Well, hopefully you're saying 2, because that's how many we're going to have. We're going to have 3 total fractions, but 2 conversion fractions. And so the first thing I want to do is write 215 feet per second into a unit rate. Because if you're going 215 feet per second, that means you're going to travel 215 feet in 1 second. Okay? Now, I need 2 conversion fractions because I'm going to change 2 units. It doesn't matter which unit you change in which fraction. Okay? I'm going to start with feet. Since feet are in the numerator, I need feet to be in the denominator in this first fraction. Well, since I'm changing feet to miles, that means I got to have miles in the numerator. In the second fraction, I'm going to use seconds. Since seconds are in the denominator, I'm going to put seconds in the numerator to help divide those out. And since I'm changing seconds to hours, I'm going to put hours in the denominator of that same fraction. Now I fill in numbers. In 1 mile, there's 5,280 feet. In 1 hour, there's 3,600 seconds. So now, doing some unit division, I guess, divide out the units that are going to divide out, I'm left with miles per hour when I multiply straight across. So when I take 215 times 3,600, I'm going to have miles in the numerator, and then 1 times 1 times 5280 is just 5280, and I'm going to be left with hours in the denominator. So 215 times 3,600 divided by 5,280 leaves us with 146.6 miles per hour. Okay? Making some sense? We've got a few more. Think about this one. How are you going to set up converting gallons per minute to ounces per second? Think about it a second and at least get your units set up in your conversion fractions, and then we'll go through it. Okay, so we're going to first have to write 5.2 gallons per minute in a unit rate. So 5.2 gallons in 1 minute. And again, since I'm changing 2 units, I'm going to create 2 conversion fractions. First one, I'm going to change gallons. So gallons are in the numerator. I've got to have gallons in the denominator to divide them out. Now gallons are being moved to ounces, so ounces need to go in the numerator. Minutes the same way. Minutes are in the denominator of my unit rate, so I've got to put minutes in the numerator of my conversion fraction to make sure they divide out. And since I'm changing minutes to seconds, I got to put seconds in the denominator. So gallons divide out, minutes divide out, and I'm ready to place my numbers. In 1 gallon, there's 128 ounces. In 1 minute, there's 60 seconds. Okay. Now, multiply straight across 5.2 times 128 over 1 times 1 times 60, or 60. My units that are left are ounces in the numerator, seconds in the denominator, and so when I multiply this stuff out, I get 11.09 ounces per second. That's what we wanted to change to. Okay? All right, great. Try converting 35 miles per hour to feet per second. Go ahead and stop the video, give it a shot, set everything up, multiply it out, and see what you get, and then check your answers when you're done. Make sure you're doing it okay. Did you get 51.33 feet per second? You can see there how the conversion fractions are set up and which units are going to divide out. And you can see how I multiply straight across and divide the numbers out. Okay? We're still having some issues with this. Make sure you come in and see me and we'll figure it all out. Okay? All right. Now, why are we doing this? Well, here's an example of where you might want to change some units. Jeff and Linda are racing to school. So they're both going to start at 12.5 miles away from school. Jeff is going to travel at a speed of 75 feet per second, and Linda is going to travel at a speed of 55 miles per hour. Who will reach the school first? Well, obviously, whoever is going faster is going to reach the school first. But the question is, who's going faster? Well, since they're not in the same units, we don't know. So what we can do is convert one of these over to the other units. Now, I'm going to take 75 feet per second and convert it into miles per hour. You could always go the other way if you wanted to. You can convert miles per hour to feet per second, and there's not going to be any problem. Okay, I need my conversion fraction. I'm going to convert the feet first. So feet need to go in the denominator, miles in the numerator. And then for my seconds, seconds need to go in the numerator, and hours need to go in the denominator. That way feet will divide out, seconds will divide out, and I'm in good shape. So in 1 mile, there's 5,280 feet. In 1 hour, there's 3,600 seconds. So we multiply straight across 75 times 3,600, and then divide that by 5,280, and we get 51.14 miles per hour. So Jeff is going 51 miles an hour. Linda's going 55 miles an hour. So who's going to get there first? Linda will get there first. Okay, that's why we do this. Make sure that we're comparing apples to apples. Okay, try this one. Jenny and Matt are on a hike. They both have 4 gallons of water. Jenny is drinking hers at a rate of 0.75 ounces per minute, and Matt is drinking his at a rate of 0.25 gallons per hour. Who will run out of water first? Well, obviously, whoever's drinking at a faster rate will run out of water first. So pick one of these guys, convert them to the other rate, other units, and see if you can't figure out who's going to run out of water first. Okay, did you conclude that Jenny will run out first? Now again, whether you convert Jenny's rate to gallons per hour or Matt's rate to ounces per minute, you should find that Jenny's rate is faster. Okay, I got 0.35 gallons per hour for Jenny's rate. Okay, so Jenny's going to run out first. So hopefully you came to the same conclusion. If not, if you're still not sure how to convert these, then again, make sure that make sure you come in and see me during STAR, and we'll get this all figured out. Okay. Homework's out in Canvas. Make sure you have that done next time.